Bismillah ar-Rahman ar-Rahim. This is Teacher Iman explaining Unit 6 Differentiation for Grade 12 done by Teacher Iman al-Khaldi. Let's understand the definition before. An asymptote is a line that you get closer and closer to, but never quite reach. In mathematics, an asymptote is a horizontal, vertical, or slanted line that a graph approaches but never touches. Or asymptote is the line which is tangent to the curve at a point at infinity. And you can have a look with me here to the line, which is that broken one. And you can see that the curve doesn't touch it. We can call this line asymptote. There are three types of asymptotes. The first one is the horizontal asymptote, which can be written in the form as y equals c, where c is a real number. The second type is the vertical asymptote, which can be written in the form x equals c, and c should be always real. The third one is the slant asymptote, which can be called oblique in the form y equals ax plus b. First, let's study each alone. First, the horizontal asymptote, which is a parallel line, which is parallel to x-axis and cuts y-axis. The horizontal asymptotes. To find the horizontal asymptote, we compare the degree of the numerator with the degree of the denominator, like this. Look, n is the degree of the numerator, m is the degree of the denominator. Compare between them. If n smaller than m, then horizontal asymptote is going to be the x-axis, which its equation is y equals 0. And if n equals to m, then the horizontal asymptote is y equals a over b, a over b, which are the coefficients of the highest power up over the coefficient of the highest power down. The last case is if n is bigger than m, then there is no horizontal asymptote. There is an oblique asymptote. From the graph below, the equation of the horizontal asymptote will be written as y equals b, and you can see that the limit when x approaches to infinity for the whole function f of x will reach b, and b is real. Have a look to the graph at y equals b, which is that broken line that we can call it asymptote, and you can see that the limit of the function when x approaches to infinity, getting closer to b, without touching it. Let's go to the second type, which is the vertical asymptote. The vertical asymptote, which is parallel to y-axis and cuts the x-axis. The equation of the vertical asymptote should be written as x equals c, and the c is a real number. We can find it by the limit when the x approaches to that c for the function f of x, and the function will go to infinity. And the infinity is not real, which can be clear in that diagram explaining that graph. Look, this line, that broken line passing through x equals c, can be called the vertical asymptote. And that curve, when the limit of the function, when x getting closer to c, the function goes infinity. Steps to find vertical asymptotes of a rational function. Step number 1, let f of x be the given rational function. Make the denominator equal to 0. Equal it by 0. Step 2, when we make the denominator equal to 0, suppose we get x equals a and x equals b. That means you're going to solve the equation. Step 3, the equation of the vertical asymptotes are x equals a and x equals b. How to find vertical asymptotes of a function. We will give you some examples. Example number 1, find the equation of vertical asymptote for the function given below. F of x equals 1 over x plus 6. The solution. You should equal the denominator by 0. Equal the denominator by 0. And the denominator was x plus 6 equal to 0. Move the 6 from one side to another by changing its sign from positive to negative to get x equals minus 6. And that will be called the vertical asymptote, which can be drawn in that way. This is our curve, and you can see that the limit of the curve when getting closer to minus 6 from the left will make the graph approaches to infinity to the negative side. That's mean minus infinity. And when the curve getting closer to minus 6 from the right side will make the curve goes to plus infinity without touching it. Another example, which is example number 2, find the equation of vertical asymptote for the function given below. F of x equals x squared plus 2x minus 3 over x squared minus 5x plus 6. Solution. As usual, we are going to take the denominator and equal it by 0, which is x squared minus 5x plus 6. If you equal it by 0, you can see that it is a quadratic equation, and it needs to be factorized by trinomial expression, which can be written as x minus 2 and x minus 3. Be sure that 6 can be written as 2 times 3, and because the last sign is positive, make the two signs similar to that in the middle, to be minus 2 and minus 3. The whole is equal to 0. Now solve it as either x minus 2 equals 0 or x minus 3 equals 0. Then x equals 2 or x equals 3. And that will give you in the third step the two vertical asymptotes, which are x minus 2 and x equals 3, which can be represented in the graph by that way. X equals 3 and x equals 2. And have a look to the curve. The curve, when it is getting closer to the asymptote x equals 2, the curve goes up to plus infinity. And when the curve is getting closer to the vertical asymptote x equals 3, the curve getting up to plus infinity. We will be able to find vertical asymptotes of a function only if it is a rational function, only if it is a rational function, otherwise we can't. That is, the function has to be in the form of f of x equals g over x over h over x. Let's have an example of this rational function. Have a look. You can see that in rational functions, you will have vertical asymptote and a horizontal asymptote. And the curve doesn't touch them. In the horizontal asymptote, it's supposed to be parallel to x-axis cutting the y-axis. In the vertical asymptote, it should be parallel to the y-axis cutting the x-axis. And the curve getting closer to each without touching them. Getting closer to them without touching them. Here also, they are getting closer to them without touching them. An example. Choose the correct answer from the graph below. Our function will be f of x equals 2x over x minus 1. From the graph, you can see that the equation of the horizontal asymptote is, we can see the horizontal asymptote here is cutting the y-axis at 2. Cutting the y-axis at 2. So we are going to choose the equation of the horizontal asymptote is y equals 2 or x equals 2 or y equals 1 or x equals 1. According to the graph, it is cutting at y equals 2. From the curve, you can see that to find the horizontal, you are going to use the limit. And the limit for a function having equal powers up and down, you're going to take the coefficient of the highest up divided by the coefficient of the highest down, which will be 2 over 1. So the answer is 2. So we are going to choose for that equation A, which is y equals 2.